Right. So basically, the sets and the probability is also tested for like more than 12 or 13% of your paper percent, right? That means you will see like 2 or 3 or 4 question in your paper one within the 25 question, and definitely there will be a 10-mark question on paper one B section on your grids and the tree diagram most likely, and there will be a 10-mark question on your sets and probability in the paper 2, that is your maths paper 2, right? Okay, so to have a quick recap of your syllabus, and also we will be working on a past paper question as well in this session with relevant to the sets and the probability, right? So basically what is meant by set is kind of a collection, right? So we divide the whole data we have into subdivide meaningful subdividing clusters. Now say for example the girls of a classroom, boys of a classroom, the students who have got more than 50% of the mark, the students who are able to draw and listen. So likewise we can classify them into different clusters, right? That is the basic set is all about. If you look at the document or the tute with you, right, and I also can share the screen. Right, the sets, right? So in the first thing you need to understand in set is that the ways to represent sets. So basically there are 4 ways in which you can represent the sets: description, listing, Venn diagram, and the set builder method, right? So description is where we give in sentence, listing is with double bracket with comma, and you can't repeat the same element again when you are listing. And Venn diagram is where with an oval or with a square, right, showing that it's A and B. You can see there are examples given to you over here, right, where you can't have commas when you are drawing a Venn diagram, and also you can't repeat the same element in listing and Venn diagram. Set builder method is where it's a way of expressing in another way, but it's very reality tested, but it's there in your syllabus. I don't want to miss it out. If you look at the first one, x is a number, right? A equal x is a number less than 5, right? Integer less than 5, and x is a prime number less than 10. So the set builder method is not much important, and it is very likely to be tested in the paper, right? Okay. And when it comes to the theorems or the terms and the theories related to set, I just want to quickly go through, right, all the theorem or the sets related theories and the terms that you have to be uh, familiar with. Number one, the cardinality, right? So I have given spaces, right, for you to write down the symbol of each, right? Because the symbolic form or the Venn diagram and all very important, but when it comes to the symbols, right? So let me also draw the symbols with you guys, right? So if you look at the cardinality, or it's the number of element, it is the simple n, right? So what is the meaning of cardinality? So the cardinality is not much used by teachers, but it's there in the past papers as well, right? Cardinality meaning it is a number of elements in a particular set. Clear? Right. So if you look at the first one, A equal PQRSTUV. So the number of element now 1, 2, 3, 4, 5, 6, 7. Number of A equals 7 over here. Right. And the number of, so the element or not element of, right? So there can be a question where you need to insert whether it's element with an E or a crossed E with not element of. These are, I know, very basic grade 9, 10 stuff, but I just want to quickly rush through, right? I don't want you to miss anything out from the syllabus, right? And also this will be very much useful for the grade 10 students as well. So element of and not element of meaning, right? Now say for example, if you look at the B, right, B equal HIJKL. So we say H is an element of B or H is not an element. So H is already there in the set B, therefore it is an element. So we write an E over there, and it is not an element, we write an E and cross, because the P is not an element of it. finite set and infinite set, or finite and infinite, right? The meaning of finite set and infinite set is where if you can specifically say this is the number of elements in a particular set, then it's finite, definitely you can say. But say for example numbers, right, or red color flowers, so you can find millions of it, so there's no end for the number of elements, that is called infinite set, right? Number of grade 11 students in a particular school or in a particular grade is a finite or definite set, right? So there can be finite or infinite. Okay, and there are two examples given to even numbers below 9 is a number of a equal 4, it is a finite set, and in infinite set. So all of them are given to you in the tute. I just don't want to go through one by one, right? And the equivalent set and equal set, most of the students get confused with this, right? Equivalent set and equal set are completely different ones, but equivalent set meaning, right, it consists of the same number of elements. Now say for example, if you look at the example given in the page number 11, right, a equal 1 2 3 and b equal syf or Sayyaf, right? So SYF has 3 letters, 1, 2, 3 has 3 numbers, where both the set A and B have the same number of elements. That means the equal cardinalities is known as the equivalent set. Only the part, right? So 5 and 5, it can be number and letter, symbol and letter. It's possible. Equal set meaning, right, the number of elements, and also you need to have the same number of elements and the same set of numbers or the elements as well. Meaning, say for example, if you look at the example P equal LOVE, right, and the Q equal ELVO. So if you look at the cardinality or the number of element, you have 1 2 3 4, so both have 4 4. And also if you look at the elements, exactly same element but mixed in the order, LOVE and ELVO, same set of elements. So these two, P and Q, we call it as equal set. So don't get confused with these two, right? And the subset. What is the meaning of a subset? Subset is where from a main set or from a universal set, we can have number of subsets. So for example, from grade 10 students, right, we can have a subset of girls or subset of boys, right? The boys who have scored more than 80, right? So likewise, you can have small subset, right? So what is the notation we use for the subsets? So what is the notation we use? It is a kind of a C, right? It is like a C that we use for the number of subset we have, right? So, and if you have like 10 elements in a particular set, 10 elements, how many subsets you can write using this? There's an equation, number of subset that can write is 2 to the power n, that is 2 to the power 10, right? If you have 5 number of elements, it's 2 to the power 5. So it is a small calculation of how many subsets we can write. This has been tested in your part 1 paper, right, as to how many subset can be drawn using it. Okay, fine. And we have another concept called null set or empty set, right? The typical example that we study is always elephant with feathers. So we can't find any elephant with feathers in this world, right? So then it's null set. But still, if a particular set has nothing or has no any elements, we call it as the null set, right? So there are two basic symbols we can give. One is having a double bracket without anything in between, or it's a blank curly brackets, right? Or you can basically draw this 0 and cut, right? That's a null set. The reason why we are revising all these symbols is, guys, this can be tested in the exam, this can be there, so you don't need to panic if you just go through by having at least 2 months for the exam. If you quickly revise it and you are comfortable with this, right? and the intersection, union, and complement. The upcoming three are the most important symbols that we will be using throughout our uh, sets area, right? If you look at the intersection, that is a N, it's not an N, yeah, and union, it's a U, and complement is A dash, right? The symbols, right? Where the intersection, what is the meaning of intersection? It is the common elements between two sets. Even grade 10 students must have studied this, right? Intersection between two, right? The intersection we will be discussing on the go. And union means it's the total element from A and B together. And remember, even when you are making the union, or when you're adding two different sets into two, please don't repeat the same element, right? Complement of A. Complement of A means it is the element which is in the universal set, but that is not in the specific set. Say, for example, if A equal 1, 2, 3, and the universal set has 1, 2, 3, 4, 5, 6, and the 4, 5, 6 is your answer. Without the A's element, what are the remaining element if you look at the complement? So complement or the A dash, right? So always remember, the complement of a set has to be compared with a main set, right? Or with a universal set. Usually universal set meaning that is the most uh, higher one, or the most universal one, which has all other subsets, right? For, say for example, colors is a universal set. Under the color you can have main colors, different colors, or you can have different sort of subsets on that, right? And then the complement of set A, right? And you can do that, right? And please yeah, go to the page number 12 in your tute. And also I have shared the screen, right? So the representing sets in notation, right? These are very basic one. So when it comes to your O-level exam is concerned, there can be Venn diagram with two sets or even three sets, right? So we have included everything in this, right? I just want you guys to hide the answer and do the question on your own after the class, right? Hide the data, and or just look at the question and do only the answer on your own and compare it with each, right? And the first one, you can see the A intersection B. A intersection B is where you have the common out of A and B. A intersection B, that is A intersection B, the common for A and B. This is very basic, right? And A union B meaning it is the total of A and the B, right? It is a total. Moving forward, this will become complex, right? So have a proper understanding. Now, what is the complement? A union B is full complement. Guys, in the Roman number 3, page number 12, very important, if you have a comma and you have a dash mark out of the comma, it means the A union B full dash. That means the dash or the complement belongs to both A union B. So you remove the A union B from it and you color the outside. I hope that you guys can see it has been already shaded out, right? That is A union B dash. But if there is no bracket, only if it is for A union B dash, right, the answer will vary with that. So Roman number 4 is where A intersection full dash, A intersection B full dash. That means we know the A intersection B is this, and without that part, all the other outside, without the complement part. I hope you guys can see what I'm drawing on the screen, right? Moving forward to the fifth one, right? Fifth and sixth are confusing for many students, right? Please don't have confusion. Now, what is the easy way of remembering this, right? And it shows A intersection B dash. That means the dash only belongs to A, right? Some students have a controversial meaning of this. So this shouldn't be union. No, this is the intersection. But the intersection meaning common for A and B, but without the entire B's range, right? So that is only the part of A belong to will come, right? Even the intersection part will not be there. Same way the other right side, A dash intersection B, this part, right? Without the A, only the part belongs to B, even the intersection part will not come, right? Same thing has been summarized into the form table format, right? And you can go through it later on, this part. Okay, right. So please take your pen and the paper and will quickly share this part. Right. Guys, keep your microphones muted. Right. So the first one, P dash. P dash meaning without the P, the entire set, right? P dash. Okay. So it is the outside of the P, if you have the meaning. Right. Roman number 2, A intersection B. It is the common for A and B, right? And the P union Q, it is the total of the P and Q. It can't go outside of P and Q, right? It has to be inside P union Q. And X dash intersection Y, this is similar to A dash intersection B. And there was a question, X dash union Y, how this can be X dash union Y. There's no such a question in your level. Don't get confused with, right? Okay. And X dash intersection Y, that means without X, the only part belongs to Y would go into that, right? And the next, moving forward to the fifth one, P intersection Q. So here you can see Q is a subset of the P, right? Q is a subset of the P. Right? So you need to shade the P intersection Q. P intersection Q means the common for P and Q only, the middle part. Right? This is a subset. A union B, that is the whole thing. The way we shade, right? Right. So if you look at this, the most complex one that can be tested in your entire syllabus is this, right? A intersection B dash, so only this part, union A intersection A dash intersection B, so this section, right? So I hope you can see it's already highlighted over here. Okay, right. And what are these two notations? Now, when it comes to events, I hope you guys have studied that there are two type of event, right? Mutually exclusive event and independent event that we will discuss when it comes to the probabilities in detail, right? So the mutually exclusive event will not stop the other event occurring. So there will be no overlap between. So the first case you can see is the mutually exclusive. If you have printed or if you have a paper, and you can mark it that this is your mutually exclusive one, to find the union. And to find the number of A union B, this is your independent. This is your independent event where there's an overlap between A and B. So we remove the intersection of A and B, right? And This is your for mutually exclusive. So there are two type of events in that. And the notations we have right in this page, the page number 14, with three sets, right, which is very much possible to be tested in the paper, in the exam, right? So you can see A intersection B intersection C, that is the common for A, B and C, all three common, meaning you have the middle, right? The middle. If you have any doubt in that, you can put in the chat box, right? I don't want you guys to leave the class without the proper understanding, right? Without right to getting it right. So the A intersection B. So here just now, when even though when you are having three sets over here and there's nothing mentioned about the C, just leave the C. Think that there's no C and mark it as A and B alone in that, and just do how we did the earlier one, right? And the part now here, right, there are some practical question in the past paper, right? Most of the time these practical questions are tested, some scenario case related questions are tested in the past paper, right? And also even in the this particular chapter, I have given you the 10-year past paper analysis on how it is tested, guys, right? Please, all everything is done and it's there in the table, and it's up to you whether you are going to do it and mark it in your done table, right? Please get use of this, right? And have a print, or at least just have it in the screen and pick all these question and do it. In every single question you see the sets and probability are mixed up and tested, right? So no question only in sets, right? Most of the question in the probability and the set is mixed up with both parts, so that's the reason it's mentioned as sets and probability. So it's there for 10 years. If you have not done, it's not too late, you can do it, right? And while you are doing, you have any doubts, you can ask me too, right? Hope you have my contact number. So the third one, A intersection B intersection C dash, that means the intersection of AB but without the point part belongs to the C. When you compare the second and the third, that is only different, where C has been mentioned as without the C, that means the dash of the C, meaning you don't mark the part belong to C out of A intersection B. Clear? And this one, right, I hope you can see my mouse pointer moving. And in this, A intersection B union C dash, that means first go and figure out where the B union C is. It's here, right? So remove the B union C, that means the entire B and C and only the part left, right? And here A union B union C, that is a basic one. And the complement of A union B union C, that means A, B, C all dash is there, right? That dash or the complement mark is common for all three. So therefore you mark the outside, which has been already shaded, right? Okay. And A union B intersection C dash, that means A and B together, but again, so compare this part and this, right? Here A intersection B, here A union B, right? So you can have a comparison and an understanding, guys, right? Have it printed and you can revise it at home again as well, right? Okay, so it's A union B, that is the part belong to A and B together, but exclude the part belong to C. So that is the shaded part, right? And the last one, A union B, sorry, A intersection B union with Fauzi Ahmad. I have to block you from the class. A intersection B union B intersection C dash union C intersection A. Right. The last one is on A intersection B union B intersection C union C intersection A. That means A B intersection, B C intersection, and C A intersection. Basically, the part belongs to all three, and also vice versa with AB, AC, and BC. Right? Okay. So these are very the important and the magnificent ones are given, and there can be even more as well. So the three sets can be of this shape or sometimes this shape, where when there's no overlap between P and R, it will be this way, right? So in the when it comes to the exam question is concerned, right, the past paper question or the your O level paper is concerned, right? Mostly they provide you an incomplete data or incomplete Venn diagram for you to fill in. Then thank God you can fill it in. But sometimes there are questions in the past paper, you can see there is a case study or kind of a paragraph given to you. You need to pick the right data and draw your own uh, Venn diagram from the root. There's nothing given, but all the data are given in sentence form, where you need to put them in jot, you can jot down somewhere, and accordingly you can draw. But in that point, you need to understand whether it's going to be this shape or this shape, right? You can't predetermine and go in the exam to the exam hall, right? So please make sure you pick the right thing, and if you can't see any common between all three, then the Venn diagram is going to look like this, right? So P intersection Q, the yeah, this is also similar to what we have already discussed, right? And the only difference is this, right? P union Q union R full dash means without P, Q, and R, you can shade the outcome. So if you understand these three basics concepts, right? The intersection, union, and the complement, right? You more or less are done with the whole thing, right? So it's important to understand how this is going to look like, and also which parties belong to, and the union and the intersection, and most importantly the dash or the complement belongs to the entire scenario or only to that particular letter. You can see that with the bracket sign, right? Guys, whatever I say is really meaningful when you are doing the past paper, right? So that is the summary of the sets you have in your syllabus, right? The notations, the Venn diagram, right? And also the sentence type questions, right? So moving on to the probability, right? I will quickly run through the probability area, and then we will work on a past paper question as well, right? And most of the past papers are on both the probability and sets as well, right? Probability is the likelihood or the chance of event occurring, right? The probability that something will happen or not, right? So probability is not for an event that has already occurred. It's like a planning. Probability is for what is going to happen in the future. We call it as experiments or the events. All the events that are happening in the future, for that we can use a probability. For us to calculate the probability of a future event, we can use the data from the past history. This is how it has been happening. Therefore, this can be the probability chance of happening in the future. For example, if you have certain colored balls in a particular box, right? Then you can have, you know, how many, which color and what is the number of it. So already you know the numbers, and then you are going to pick it. So when you are picking it, you are going to do a random experiment. What is the meaning of random experiment? Is where we can't say there are 4 or 5 features of a random experiment, but basic understanding of a random experiment is that it is an unbiased experiment. Unbiased meaning you can't be partial to some, right? You have to be in neutral and you pick it. So say for example, if you are going to pick a ball, you can have all of them in the same size or can be a difference. So there can't be unbiased, right? Random experiment meaning you can't say the outcome of the event before it is occurred, right? So these terms in the probability, the event, occurrence, right, unbiasedness, random experiment, sample space, all of them are specific terms that we use in this chapter alone. Probability, you won't see this in your day-to-day life, right? So how do you find the probability of it? So the equation is there in the from your syllabus. It's a typical equation, the number of favorable outcome divided by the total number of possible outcomes. So it's a probability of one event with regard to the all the other outcome we have, right? Say for example, you have numbers from 1 to 10, where you are going to pick only the even numbers. So even number is your desired or the favorable outcome, but you have the total possible outcomes from 1 to 10, right? So likewise, be precise for which event am I going to calculate the probability for, right? And if there is an event that will happen for sure 100%, right? If it is happening 100%, the probability is 1 in decimal, or in 100% means it's 100 in percentages, right? So most of the questions on probabilities are given in terms of number ranging from 1 to 0, or as a percentage, both fine. If it is 0.2, that means it's 20% chance. 0.8, 80% chance. So there is a 70% chance of raining, meaning 30% chance of not raining, right? So you can see the last point over here in the page number 15. The probability of something not happening is 1 minus the probability that will happen, right? For example, the probability of you passing the O level exam is, it must be 100%, yeah. So for someone, if it is 80%, chance of failing is 20%, right? Okay, so that is the basic understanding of the probability is all about. But you need to be very clear with the event, how this event is going to be, whether this event is going to be mutually exclusive or independent. Let's discuss on that part now. So the type of events, now when it comes to your O-level exam is concerned, we can classify the number, the types or the events given in your throughout the past papers into simple event and composite event. Simple event meaning it will have only one outcome. So this is very basic and you just pick only one outcome. Where in the composite event, right, the events which are not simple are called composite. So any event which will have more than one outcome will have composite events, right? So say for example, if you write an exam, you can't pass and fail both, right? So if you pass or fail, right, only one outcome can be there. So that's simple event. Okay, but out of passing you can have A B C D, or you can have A B C S, right? So that is a composite event. I hope it's clear, right? Okay, and then based on the steps also we can classify your events: single step, two step, three step, four step. But in your syllabus we have only single step and the second step. Okay, for example, you pick a ball and you mark the color, and whether you put it out or put inside, based on that you pick 1 and 2, or parallelly you can toss a coin and a dice. That is a two-step event where parallelly you will have continuously or simultaneous events. That's called the two. But of course in the exam maths paper you are not going to have write the definition of two-step events, no, but you need to have an understanding while you are reading the scenario. Yeah, it has to be clicked in the mind. Okay, yeah, this is the area we are there. Okay, fine. Okay, and then equally likely events, right? Equally likely events are events that have the same probability of occurring. For example, numerical on an unbiased dice is equally likely to occur when the die is tossed. So that means your random experiments must have equally likely events. That means your outcome should not be partial, right? And then the most important comes here, the independent event or mutually exclusive event, right? Now say for example, from morning 8 to 11, if you are in the seminar, right, meaning the occurrence of this or attending the seminar definitely stops you attending another class, right? That means This is mutually exclusive. Independent meaning you are attending the seminar, parallelly you are chatting with someone. I know it's happening. And also you are having your breakfast. Independent events, right? Seminar goes on and you are having a breakfast. That's fine, no problem. So independent event is where the occurrence of two events are not affecting one the other. Passing your O level, also passing your AAT exam. There's no any correlation between, right? So the independent event is where you have no correlation between these two. So you can see, right? And the mutually exclusive where only one happens, the other can't happen, right? Okay. And also the complement on event of an event means the same meaning, right? Union, intersection, and the complement of an if event meaning, right? You are having the same set of meaning which we studied under the sets, right? Right. So how are we going to, or how are we tested on this probability question, right? It is most likely that you are tested on contingency tables, where the contingency table is having row and column information. For example, if you see male and female and their pets, dog and the cat. So you see the total is 100 always, right? So the total of the column and the total of the row has to be equal. And if you see the eye color with male, female, right? Black, brown, blue, green, and gray, and the total is 85 plus 82, 167. And also from each side, the color wise also it's equal. So from a contingency table, you should be able to find the probability, right? So there's a note here. The total number of rows and the total number of column of the contingency table should always be equal, so that everyone knows. And if you want to find the probability, now let's say find what is the probability of, right, female having cat as their pet. That means 39 is the female and number of cat, and out of 100 it's how much. So the probability of having cat by a female is 39 out of 100. And also when you are giving the fraction, if it is simplifiable, simplify and give the most simplest smallest answer. Clear? Right. Another example, let's say what is the probability of a male having a gray color eye. Male having a gray color means it's 10 out of 167. It's not always out of the total. Also, they can sometimes ask out of the female students, what is the probability of a girl can have a black? That is 20 out of 85. So likewise, pertaining to which total they are referring is very important when it comes to the probability, right? And the reason why we have picked this, and these two questions are the sets and probability and the area we discussed earlier, are a must question because it's there in your part 1b section out of those 5 questions which you can't leave, right? And also I strongly recommend you guys to pick this set and probability question and also the frequency distribution question from your part 2 paper as well, right? Because these are kind of not complicated one rather than the kind of construction and the theorems related ones are also kind of uh, complicated ones, right? Which for which also we will be having a seminar on 9th of January, right? Okay. And the grids, right? Starting from the grids, right? When you are drawing a grid, guys, it is very important to see whether your event is independent or mutually exclusive, right? I'm repeating this over and over again is because there are many students get confused with this. Mutually exclusive meaning when one happens, the other can't happen at the second time. It can happen only once, right? Independent meaning you can have the same happening over and over again. So you there are two grids given, and thinking that we have like 5 colors, right? So let's say we have brown or blue, black, white, right? Yellow, orange and pink, right? There are four balls or five balls, and we have B, W, Y, O, P. Same way we have the same thing, right? B, W, Y, O, P. Okay, fine. Now out of these, right, now let's say these are balls, right? There's a very important note here, guys. Here, horizontal axis to represent the outcome of the first draw, it is a must. Okay, when you're drawing a grid, you must select the horizontal line as the first event always, and the vertical as the second event, right? So this will be your first event. The horizontal will be the first draw. This is your second draw, right? Don't get confused with this, right? Also you can mark it, right? So let's say out of these five balls, right, I'm giving two scenarios. One scenario is where I pick a ball and mark the color and put into the same box again. That means that same ball can come out in the second event as well. That means the occurrence of the same ball, let's say the red color came or the blue color came first, that can come again. So that means you are, when you are ball or when you are marking it on the grid, you need to mark every single thing, right? Every single possible outcomes, right? So having, you can have dots or even you can have small cross. So all 25, 5 into 5, 25 must be marked when you are having an independent event. If there's any confusion in this part, you may ask in the chat box. When it comes to the mutually exclusive event, now only the important thing that you need to understand here, right, is the same blue can't come again. Same white, same yellow, same orange, and same pink, the same colors can't come, which means this line, these lines can't be colored, right? That means you are going to mark this, and this. Right. So most of the exam question will have the drawn grid, right? So maybe dotted or maybe the color is fine, right? And these are the one that will not come. So the most important thing in the exam, you can have these marked in pencil first. Okay, these should not be marked, right? And we will be marking all the other. I hope it's clear. So blue, blue, white, white, yellow, yellow, right? This corner, the origin is left over, right? So here the total outcome or the total sample set has 5 into 5, 25 numbers. Here 25 minus 5, that is 20, is the total number of outcome possible. There's a question in the chat box. Right. So the mutually exclusive, can you sir explain again, right? So the mutually exclusive meaning in this, right, the right hand side, the red color marked are the mutually exclusive. Meaning of it is the blue ball. Now let's say when we take a ball from the box, the blue ball is taken, we mark the color and we throw it. We don't put inside the box again. which means since there is only one blue, right, and there's no chance for a blue to be occurred again, right? But if you mark the color and put into the same box, meaning that blue can be picked up in the second or third, it doesn't have a problem because the same ball can come over and over again because you are repeating the same by putting the ball inside the box. Okay, so that is your mutually exclusive event, right? Throughout the session or throughout the syllabus, this mutually exclusive and independent is very important, right? If one happens and if it cannot happen again, it's mutually exclusive. If the same thing can happen again, it means it's independent. Okay, I hope it's clear for everyone. Right. And using the grid, right, you are asked to, right, draw, or you are asked to mark some sort of thing. Now say for example, you will have to mark these, right, with a particular condition, right? So we will be doing a question on this, right? Sometimes you will have to mark, or you sometimes you will have to circle it out, only these, right? So likewise we will be doing in the past paper question that I have selected for, right? So sometimes we will do like this. So fine, moving down to the tree diagram, right? Tree diagram is also another way of repeating the same events, right? And the tree diagram of an independent event and the mutually exclusive event are given to you here, right? So tree diagram will have 2 or 3 branches. Maximum of 3 branches can be tested in your levels, right? But usually it is the two wing is the one that is mostly tested, right? So when it comes to independent event, right, you need to make sure and you understand this part, the denominator of this, right? So here 3 over 8 is for the blue and 5 over 8 is for the white, right? So this is the first row they do and this is the second row. Okay, so out of the first row, if you see, the probability of the black being selected is 3 out of 8. Therefore the balance out of 8 is 5 out of 8 is for the white. That means 8 minus 3 is 5. It's already marked there. When it comes to the second row, you will see the difference between independent event and the mutually exclusive event with a tree diagram only in the second row, right? So when it comes to the second row, if you have the same denominator 8, then it's an independent event because there's no difference, there's no reduction in the total event or total number of outcome we have. Clear? Okay, and then same way here, so we have all the same, right? And the outcome blue blue, sorry, black black, black white, white black, white white. So you multiply them, 3 over 8 into 3 over 8, you get this. 3 over 8 into 5 over 8, you get this. So I hope you know how to calculate these probabilities, right? And there might be question on answering. So after encircling, do we need to write the Q or question number by drawing on an arrow? So when you are marking it in on your grid, right, they specifically mention in the paper, in the question, mark this particular encircle as A, B, X, Y, right? Then you can mark it there. So just circle it out and say A or B. If it is nothing mentioned, you can go and mark the question number, but there will be question with chances for you to draw with a particular letter, right? And moving on to the mutually exclusive event, guys, right? As I told you here, the first choice and the second choice, right, has blue and green. But however, if you look at the denominators, right, right, first choice 7 over 15, that is for blue, and 8 over 15 is for the green. So that means 7 for blue means the total should be 15 out of 15, so that is the 8 out of 15. Clear? So blue and green. Now there's no difference between independent and mutually exclusive in the first event. So okay, in the first occurrence of the first event. When it comes to the second, then definitely there is a difference. What is that? When we have in the first event, or in the before occurrence of the first event, we had total 15, let's say number of tiles, 15 tiles, out of which 7 blue, 8 green. You pick a tile from it, you mark the color whether it's blue or green, and you put it out. You don't put inside the box again. Then your total 15 drops by 1, but we never know which color it was, right? Because it's a random experiment, right? So the second, when it comes to the second choice, we reduce the 15 by 1 because 1 went out from the box, so it's 14. So in this branch, in the second branch, 14 out of 40, 14 should tally. So since it is the blue and the blue branch, we deduct 1 from the numerator as well, because we assume it was a blue color that went out, and we make the 7 as 6 and the denominator as 14. So to complete the 14 out of 14, there is no difference in the green color, that will remain as 8. That means in the first branch, in the upper branch, we assume it was the blue color that went out. Okay. And in the second part, right, in the second branch, we assume the green color has gone out. So therefore, the 15 becomes 14 and the 8 of the green becomes 7 here, assuming that the green has gone out. So therefore, there's no change in the blue. Don't get confused with this part, right? I hope this is clear. And also you can calculate the outcome and the probability as I shown in the earlier tree diagram. Say for example, this part will be 7 into 7 over 15 into 6 over 14, right? You will calculate the total. So likewise, you can fill it in, the probability. So the most important thing here, you understand whether it's independent event or mutually exclusive event. So in first branch, green total is 15. No, green total is 8 out of 15. And the total number of tile we have is 15, out of which 7 blue, 8 green. Okay, cool. Yes, as we assume that blue is taken, green remains the same. Exactly, right? Cool. Okay, so it is out. The third branch or the third choice is very unlikely to be tested, but it is possible. But in that case, it will remain reduced by 1 more. So don't get confused with that. So do the past paper and try to understand. Okay, and while you are doing past paper, and also you can refer to the answer, and you don't understand, and you can reach out someone to ask, right? Okay, so the most important thing we have here is the rule of probability, right? In probability, right, sorry guys, the rule of addition and rule of multiplication. When you are reading a question on probability, be vigilant. That means you have to read every single word very carefully, meaning there will be a word called O, the OR, A O B, X O Y, blue or black. Same time, there will be a word called and, red and blue, white, A and B. Depending on that particular word O or and, by combining two events, the rule will change. If it is connected with O, we call it as additive rule. O, either A or B, right? What is the chance of me, right, getting that particular thing as 100% or 90%? Then you add up them, right? That is possible for independent events, right? And also even the AND rule we can use for multiplying, right? So the fraction should be added or the fraction should be multiplied is the confusion by many students in this particular area, right? So when it comes to addition rule, right, I don't want to read this one by one and explain, but try to understand. And meaning you are multiplying, O meaning you are adding. So that is a short way of keeping it in mind, right? When you study your A levels and afterwards, you will study this in detail. And rule or rules are very deep, but for your O level is concerned, you can go in that way, right? So for example, you can see the AND rule, probability of A and B, probability of A and B, or AOB, right? So AOB meaning we add the probability of A with the probability of B. We add because there's an O rule. Probability of AOB, right, with a the independent event will have probability of A and B deducted. The same thing we have gone through in the set notation as well, right? Take time and go through. You'll understand, right? Compare that page with this, and sets and probability have the same meaning, right? And the multiplication rule. When it comes to multiplication rule, there's a small typing mistake in this, right? It has to be P and it's not O. I hope you are clear with the point. There's a typing mistake from the typist. It has to be A and B, okay, equals probability of A into probability of B, right? Please mark that, right? Only that difference, right? So while we do a question, we will discuss this in detail because you will understand even clear, right? So for this purpose, I have chosen one paper question, that is your 2017 paper 1 question number 5. If you have done this, perfect, all right, but let's confirm and redo it, okay? So the GCE O level 2007 paper 1 question number 5, from your paper discussion, it is this paper, this question that we are going to do, 2017 question number 5, right? You are done almost. We are going to do it, right? And you can do all the rest of the question, please, and tick off, right? So everything is there, so it's up to you whether you're going to practice or not, right? So guys, please do a good job and go to the exams, right? Okay, let's do this question. A box contains 5 bulbs which are identical in shape and size. That means they are not unbiased. There are no multiple size, no multiple shapes. Same identical shape and size. So 5 bulbs altogether, right? Of these, 2 are burnt out. Burnt out. Then let's say burnt out means B1, burnt out 1, burnt out 2. B1 and B2, right? And the rest are good bulbs. So good bulb means let's say G1, G2, G3. That is a differentiate. Good 1, good 2, good 3. Okay. Here is the most important sentence, right? A bulb is drawn randomly from the box and examined, and without replacing, guys, highlight this part 100 times. Without replacing and with replacing plays a major role in this. So without replacing meaning you take one bulb and you don't put inside the box again. Without replacing, you don't put it again, so that means the total is going to drop by 1, which means this is a mutually exclusive event. Clear? Because if you choose the burnt out bulb number 1, then you put it out, you don't put inside the box again, so that can't happen again, right? Even in your second row, right? Bulb. Another bulb is drawn randomly from the next the box examined. Use the symbol X to represent the sample space of the experiment of drawing bulbs in by B1 and B2, and the good bulbs are denoted as G1, G2, and G3. Right? Okay. So since this is a mutually exclusive, we should not mark these ones. Right? So let's cross them. 1, 2, 3, 4. Right? 1, 2, 3. 1, 2, 1. Right here. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. right, make sure this corner is left out. So 5 into 5, 25, but 5 we have not marked. So total number of chances are 20. Now they say in the grid, right? This is the encircling part, the Roman number 2. So Roman number 1, we are done, right? This paper, you are going to do it on the paper itself, right? Because paper 1, question number 5. In the grid, encircle the event of drawing at least, right? At least one burnt out bulb. At least one burnt out. What is the meaning of at least one burnt out? At least one burnt out meaning, right? There can be two burnt out as well, right? So at least there must be one burnt out. So both can't be good bulbs, right? So it can either be 1 and 2 both are burnt out, or first one burnt out, second blue good one, first one is good, or the second one is burnt out, right? So out of which we are going to select which one. So first take your pencil and you can mark which ones am I going to encircle, start without starting encircling it, right? So you can't have uh, good and good, so you have to mark. So you can have BB, this one, right? You can't have, yeah, you can have B1, G1, right? So this you are going to take burnt out, burnt out, good burnt out, good burnt out, here good burnt out, good burnt out, right? These are the ones that are burnt out good. So here burnt out good, burnt out good, at least one burnt out. So burnt out good, right? Also you can have this, right? You can't have G1 G2 or G2 G2 or G3 G3 likewise. So now you're going to encircle it and say, here they say in the grid encircle the event of drawing at least one burnt out bulb. So here only one encircling is there, so you can just leave it, or even you can mark as Roman number 2. But if there are multiple encircles tested, definitely they will ask you to draw A and B. So the encircling part is where here the question they say in the grid encircle the event of drawing at least one burnt out. So at least one burnt out meaning there can be one burnt out or two burnt out. Both can be burnt out or one can be burnt out. So the options are, since there are two events, first can be burnt out, right? And the second also can be burnt out. First can be burnt out one, second is a good one. First one is a good and the second one can be a burnt out. But make sure you can't have good one and a good one in both events, because at least one has to be burnt out. So that covers here, right? So all these red marks ones are with B1 B2, B1 G1, B1 G2. So B1 and all the other, B2 with all the other, and B1 all the other. So only the left ones, the ones that are outside the blue crosses, are the ones that are not drawn. Okay, so that is on the grid part, right? For the same event, they say an incomplete tree diagram relevant to the above experiment is given below. Complete the tree diagram by indicating the corresponding probabilities. An incomplete tree diagram relevant to the above experiment is given below. An incomplete tree diagram relevant to the above experiment is given below. Complete the tree diagram by indicating the corresponding probability. So we have identified that this is a mutually exclusive event, right? So if the good bulbs are 3 and 2 out of 5 is your burnt out bulbs. And when it comes to the second row, guys, right, in the first branch, in the upper branch, we assume, right, the good one of the good bulb has been taken out because they are not replacing, right? So this, the 5 drops to 4, and since we are assuming the good one has gone out, it is the 2 left with the good ones. In that case, since we are assuming in the second row only a good one has gone out, there's no change in the burnt out bulbs. 3 out of 5, because anyway in a particular tree diagram both branch has to be equal. Sorry, it has to be 3 out of 4, not 5, because one has already been taken out. In when it comes to the lower branch, we assume since this is the burnt out one, in the burnt out we make it 1 out of 4, and there's no change in the good ones. I hope it's clear for you guys, right? I hope it's clear. Which one is 2 out of 4? Now here we had already 2, 3 and 2, right? Since the burnt out is taken, right, we assume, and the 2 out of 5 becomes 1 out of 4, both numerator and denominator reduces by 1. Okay, so this is 2 over 4, 3 over 4, 3 over 4, and 1 over 4. Clear? Using the tree diagram, find the probability using the probability, yeah. In second row, B branch 2 over 4. Yeah, this is, yeah, 3 over 4, right? Yeah, it has to be 2 over 4. Yeah. So the total has to be always 2, 4 out of 4, right? It has to be 2. Okay. Isn't the second row 1 out of 4? Yeah, it's 1 out of 4. Right. Using this, we are going to answer using the tree diagram, find the probability that exactly one of the 2 bulbs that are drawn in this experiment is burnt out. So probability, yeah, it's fine. Using the tree diagram, find the probability that exactly one of the 2 bulbs that are drawn in this experiment is burnt out. So exactly one bulb has to be burnt out. So therefore, we have to go good and a burnt out and a good. Only these 2 branches are possible for us, right? So because both good and the good can't be, and both, so exactly one of the 2 bulbs are burnt out. So probability that exactly one of the 2 bulbs that are drawn in the experiment is burnt, right? So the answer is going to be 3 over 5. So that the Roman number 4 part, 3 over 5 into 2 over 4, or meaning we are adding, right? So that is 6 over 20 plus 2 over 5 into 3 over 4. Same 6 over 20. So the answer is 12 over 20. And if you simplify 12 over 20, if you simplify 6 over 10 or 3 over 5. Right? And here comes your past paper analysis, right? and definitely this part is also tested, right? So in both paper, maths part 1 paper and part 2 paper, it's tested, right? So sets and probability part paper 1 and paper 2. So if you have any doubts in this, so how would the probabilities be if the event is independent, right? So if it is independent, the probabilities will be, right? Now, now let's assume this particular tree diagram is when, yeah, where they replace one with another. So this is very simple, right? 2 over 5, you copy the same, 3 over 5, 2 over 5, 3 over 5, 205. If it is independent, that means they keep the bulb again on the same box. They just pick it up, check whether it's burnt out or a good bulb, and you keep in the same box. So that in that way you can calculate the same. So only the difference that you can see in this is with the experiment, whether it's mutual exclusive or independent, right? Okay, it is the fraction that really makes the change. Okay, I hope it's clear. So I can give you another 5 minutes for you guys if you have any doubt in this particular area to ask, or anything related to the whole area that we have covered for. Get it printed, and we have everything marked here, right? All the past paper. So if you can see the past paper analysis of the last 10 years, right? Every single paper has a question, both papers, paper 1 and paper 2, on sets and probability. So just allocate like 2-3 hours at a stretch, keep doing. Take a paper and the past paper, sit with the past paper and do it. Then there, whatever the question comes, you will be able to answer, because the past paper will have a pattern of repeating. So if you do the last 10-year past paper, definitely you are going to come through or come with the paper that, or question that you have already practiced. So yeah, someone asked to explain the tree diagram again, right? One last time I can quickly explain this. So here the first row and the second row, right? In the first row, they have 3 good bulbs, 3 over 5, and 2 burnt out bulbs, right? In the question, they have mentioned in the experiment, they are taking one bulb, right? And they don't replace it, right? They keep it out. So therefore, we assume this is a branch, right? For the future, how it can happen. So even a good one is picked up, right? We assume second one is also a good one, right? So by assuming this branch is with a good one, we will have only 2 good bulbs because one has gone out. So the total also drops by 1. Since we assume the good one has gone out, we will take the bad one, or the burnt out one is still remains, that is 2 out of 4. That is the upper branch. And the lower branch, we can have, we assume the burnt out has been picked up first, therefore for the second row there will be only 1 left. In that case, the good bulbs, all 3 remains, right? So then you can calculate their respective probabilities and get the number sorted. Okay, fine. So the last time I can explain the random experiment and the mutual exclusive and independent, right? Guys, basically mutually exclusive is where one event, the occurrence of one event will affect the occurrence of another, right? You are in the seminar and you are cutting another class, or you are not attending another class, that has a mutually exclusive thing. Same way, I have 3 different colors of markers where I'll pick blue, and if I don't replace it, so okay, always look for the replacement, whether they are going to replace it or whether they are going to uh, replace, right? Or even they are going to have put it in the box again, right? That is the part which makes a difference. So if they keep it again on the same box, it is an independent event, because one first event happened, okay, and if the blue is picked up, second also the blue is possible, because the blue goes back to the box. If you don't replace, or you take the blue out, that means this particular uh, blue cannot happen again, because if there's only one blue, there will be no chance for you to choose the blue again. So therefore blue will become an exclusive event, right? Okay. Okay guys, so I hope the parts we covered are clear, right? And we have